Welcome, everybody. Tonight we are working on Unit 4 in our Intro to AI class. The topic for the evening is the domains of AI. There are a number of slides in here, and I was saying this before, that I'm going to gloss through really quickly. This is the stuff that we talked about last week. I think we talked about it enough last week that we don't have to talk about it again. But just in case you forgot, there you go. That was the list of topics. And then they have these little questions here, and most of them I am going to skip over, but I think this first one's probably pretty important. Which is the correct answer? Looking in the chat to see if anybody answers this one. Yes, no, maybe. Now you guys are going back to the previous unit and you're looking it up. Yeah, that is correct, sir. Digitalization is the correct answer. All right. And then they have this other one here, right? And this is if you remember your stuff from last week, and I'm not really quizzing you on it, but the thing that was missing is leadership support. And this is true of any technological change within an organization, is you have to have the vision to do it, and your admin's got to want to do it, and then the people doing it also have to want to do it. And as you guys learn when you work in tech, change is the one thing that most people don't ever want to do, right? They like the way their app is working and the way stuff is going, so why change it? More open quiz questions here. Yes, AI can help farmers in all those ways. But let's get into the materials here. And once again, I still have some slides I'm going to kind of gloss over, so just be mindful of that. But there's this quote that they're looking at here. And, this is like the stuff that science fiction is made out of, totally, right? People dreaming about making machines that have the characteristics of human intelligence and basically that can think and act like humans. Do you think it's possible? Right? Okay. Well, maybe 20 years ago you'd be like, yeah, not quite. But now you gotta admit, like if you use like Gen AI engines, it's like, man, some of those are really, really smart. Heck, they got their own social network now. We talked about that last week, right? You know what the big problem on that social network is now? Humans have discovered it. Now humans are going in there and messing with the robots, the AIs, right? Yeah, so I think that's pretty weird. But do you think it's possible? I mean, that's a pretty big question, and it's hard not to be a technological optimist and not think isn't possible. Eventually, it will really truly be possible. The question is, how long will it take to get there? And we have been heading very, very, very quickly towards trying to make it a reality. And there's so many different aspects of it that we have to think about, that really to create what we're talking about really kind of involves the fact that we're going to combine all the different areas of AI together. And for those of you that are studying this topic and you're kind of new to the program, right? You're probably in your second semester, of instruction at this point. When we start to look at AI, and you wonder why is it bundled in with data analytics, because they go together, folks, and you're going to see that is one of the first areas that we talk about. But AI falls into a number of different areas. So we're going to learn about all those different domains, and we'll learn about some areas that you'll be learning about later in our program. And all the different domains of AI, by the way, have a unique course in the program, and that includes machine learning / deep learning combined with computer vision and natural language processing. We have discrete courses in all of those. Yeah, and you know what? When we start to use AI, how do we, like as users, as we're learning about it, understand what kind of tools we're really interfacing with? I mean, it's kind of naive to think that really an AI is necessarily intelligent and has human-like features. But we can figure out what the different domains are for the different tools that we're working with. So these are the big questions that we're going to answer in this section, right? And here's a broad listing of some of the domains of AI. And some of these I would call primary domains. For example, machine learning is a primary domain. Natural language processing is a primary domain, and so is computer vision. And those are courses that we do teach here. The other things are sometimes aspects that are intertwined. So, like deep learning and neural networks are part of machine learning. Robotics are kind of like applying AI to automation tasks. And you could even think of like a self-driving car as kind of a robot, right? But a robot isn't necessarily smart per se, right? Then we have things like expert systems and statistical data, where expert systems are really kind of, I'm going to say, I might lump those into natural language areas. And then statistical data kind of drives all of it. But all of it is important to AI, all of those different bullet points. It's hard to argue that maybe the most important aspect of AI is this thing called machine learning. Um, and let's look at some of the formal definitions here. It says it's the study of computer algorithms to make predictions based on existing data. So in order to you know, predict how things are going to go, we look at the information we already have. Like after the first half of the football game yesterday, you could tell it was going to be a low scoring affair, right? Like it'd be rare to see a touchdown, right? Not what I would have predicted going in, though, for sure. Um, and okay, it says by using statistics, it aims to find a pattern in the massive amount of data and thus create a rule to make decisions. So, in other words, if I look at information and I'm noticing that there's a certain pattern in the information, I can probably guess pretty accurately what's going to follow based on what's already happened, right? If I walk up to the plate in a baseball game and I'm not a professional baseball player and somebody's throwing a 90-mile-an-hour pitch at me, it's probably unlikely I'm going to hit it. But if I'm a professional, it might happen, right? Yeah. So, and I can look at that data and I can go up to bat like 50 times and go, yeah, all 50 times he struck out because he can't hit a 90-mile-an-hour ball. But a pro could probably do it 1/3 of the time. Look at the batting averages, right? That's about where they reside. Um, and so basically, we look at information and we can set up rules for predictions, right? And machine learning actually looks at what's already happened, right? And that data that gives us what's going to happen. But so notice that rules and data in like a classical programming approach, like if you learn how to code, right, that gives you your answers because, well, somebody told you what to write as an algorithm, right? And so that you can feed data into it and you know you're going to get the right answer. But machine learning, you don't have the answer. Well, you kind of do. You start with what's already happened and you're trying to figure out what the algorithm is, to generate the rule so that you can figure out other answers. You see like the difference there, right? So we're looking at what's happened as opposed to like what you're being told should happen. It is a difference. So it's a matter of learning. Machine learning goes deep though, right? So there's this aspect of it called deep learning, which is basically we build machine learning by using what we call a neural network. And the concept of a neural network is to simulate the neurons in a brain and sending information into them and how it's processed and how it moves through the network. So, like when you have a thought, how do I get from this piece of information to something happening? Right. And deep learning, basically, all it does is it expands the layers of the neural network from the starting point to the end point. And we have many more layers of neurons, basically a bigger brain, and the deeper it goes, the more in principle accuracy we have because there's more thought that goes into it electronically. And pretty weird. We can have layers in the network that do all sorts of different things. But the essence of machine learning truly is you look at what's already happened and try to figure out what's going to happen next as a result of the stuff by just looking at it, not necessarily by being told. And I think that's really bizarre. So neural networks, as I just said, try to simulate like what happens in a human brain. I always find it really fascinating that the concept for neural networks is not a new one. It literally goes back like 80 years or something like that, that somebody first thought about, like, when computers were barely a thing. Somebody's like, well, hey, how do we simulate a human brain? Well, we got to simulate the neuron somehow, right? There's different types of neural networks, and they point out a couple of them here. So we have artificial neural networks or simulated neural networks. And all of those kind of get bundled into this whole deep learning and deep, uh, the deeper aspects, the multiple layers of neural networks. Ultimately, our brain is the model. I'm not sure that's a great idea, right? Sometimes my brain is firing on all cylinders, and sometimes not so much, right? Think about how you feel when you're tired, that type of thing. We also look at robotics, and robotics are kind of like where we have machines that do work. Now, the image that they have here is of like a humanoid robot, but in reality, most of the robots that are out in the world doing tasks today, and there's many, right, are machines, right? They might be robotic arms or robotic vehicles or a combo of both of those things. Robots, and I would put like autonomous vehicles in this category too, are basically machines that use information to basically perform tasks, right? And you can read here like the various things that robots can do. I know that in manufacturing, it's a really big move to get robots, into the manufacturing floor, because robots always show up, they don't complain, they don't ask for more money, et cetera, et cetera. And they work 24/7, right? And they work pretty reliably, provided they don't fail. Robots are often equipped with many of the technologies that are associated with other areas of AI. So, like, they often have various types of sensors, they're controlled by data. And in many cases, robots are really not necessarily AI driven, a lot of the robots that we think about, but some of them are, right? A self-driving car would be a good example of one, because it has to make its own decisions. We also have these things called expert systems, and basically you could think of these as knowledge repositories, basically. So if you have like a collection of knowledge that you've accumulated, you can take that knowledge and throw it into like a database, right? And then when a user wants to extract the information from the expert system, it would query it. So, for example, like these days when we do like web searches, a lot of us have the AI thing turned on, right? So, like, we don't even look at the search results anymore. It's like, hey man, what's the formula for something, right? And it gives you the answer. Or who is the movie star in this movie, right? How does it pull that information? Well, it has a knowledge base that it's working from. In terms of, let's say, enterprise situations like big businesses or government entities or things like that, where an organization might have a knowledge base that's been, turned into data. And then when you ask a question of the expert system, it has a spot to pull it up from. Right. All right. So the other domains, right? They're talking about these three are basically we're gonna talk about them um, in a way that makes sense relative to the data that drives them, right? And apparently this video is not working here. Not a big deal. All right. So data in a data set. So raw data is just raw information. Sometimes it is organized, and as they say here, it's processed. Sometimes it's not. It can be very raw, and it can be all sorts of different things. Words, numbers, images, videos, whatever. Right. That's typically what data is. A data set is when we take the data that we have and we collect it together to kind of organize it so that it's more of like a set of information, right? So these are just words that we use a lot in these areas. So data's in data sets. And I don't know if I missed a slide there. Nope, just the graphic coming up. All right, so just different examples of data set types, right? So there's the word types, so like it's text, right? It's either typed in or somebody speaks the words, and we have systems that convert the spoken words into text, right? Or else the text is already generated somewhere. We also have data sets that are based upon speech, right? So this is kind of weird because I can take the speech and turn it into text, but on the fly, think about this. If you're like talking to like Siri on your iPhone, it's like on the fly interpreting your words, turning them into text, turning it into some meaningful action, and then giving you the words back. So that really the raw form of the speech becomes data also, right? And if you could look at speech as a waveform, how is it goes from like these like frequencies and waveforms and it converts it into words and understands it? That's really pretty astounding, actually, when you start to think about it. That's even a possibility. Um, we can also have data sets that are images. We can have data sets that are videos, right? So, and you see some of the examples they have listed here, really good examples for sure. Um, all right, so and I like the computer vision one here too. Like if you can imagine like you're driving a self-driving car or something, and I'm not sure that's what we're looking at here, but a computer vision system can look at all the things that happen in the real world and convert them to data points, especially those things that it might interfere with its pathway. I think that's pretty interesting. But statistical data, computer vision, and natural language processing are heavily, heavily, heavily lean on the information that's provided to them in order to function correctly. So, all right, let's talk about statistical data. And that's kind of like the stuff that we're starting to learn over in the data analytics class, right? So, this is where we have words and numbers, right, that are organized usually in tables or in a database or whatever, CSV files, if you will. And then when we look at computer vision systems, right, so we're looking at graphics and video and all that stuff, and that's data for that system. And if you guys, look at like a text document and you see how much space it occupies in the computer, and then you look at an image, and then you look at a video, and think about like if I have like I don't know, a 2 hour movie and it's like super high def, how much data is that, right? Versus a document with words in it, right? A lot of data. Natural language processing too. Like, can you imagine that we have already Gen AI engines, and you can go to ChatGPT, or if you want to use Siri as an example again, like a voice assistant kind of thing that can on the fly process your words and not only get the individual words, but understand the meaning of them if you structure them a certain way, that it's like a question or you're asking it to do something, and that it understands not only what language you're speaking, but your question and gives you a meaningful response. And then have it blow your mind even more that it can do it in other languages also. Like, wow. Like, how did it figure out how to do that? Yeah. Well, read a lot of books, I'll tell you. And that sounds kind of goofy, but they figure that out by giving it large volumes of information to process and learn from. That's how they do that. So really large data sets to do all of those things. All right, so we're going to skip over that little thing. And I think this is kind of interesting thing here. It says most of the world will make decisions by either guessing or using their gut. They'll either be lucky or wrong. All right. Have you had those circumstances? I want you to think about that. You walk into a place, you're like, I don't like the looks of this place. Let's get out of here. you know, but maybe like what you're seeing isn't, resonating right with you. I think it's a pretty profound quote. Now, that's not how AI works, though. AI is going to work on data, but there's that gut feeling, right? What's the gut feeling based upon? Well, if I walk into a place like a restaurant and it just smells really bad, and it looks really dirty, and I don't like the looks of the people dining there, all those factors, right? Um, is it really a gut reaction, or are you working on data? The smell alone is enough to chase some people out. Yeah. Computers do not make decisions by guessing. It's just not how they work, right? So they always use data, and usually statistical data, to predict things, to make decisions. And statistics and statistical data are super important for a lot of different reasons, obviously. Um, the fact that we run this data analytics program, and it's really heavy on the data parts, and it's really heavy on the programming and the AI stuff, um, is not accidental, right? Statistics is something that we also ask that you study. So like, compared to most of the degree programs here at Gateway, most of them require one math course. Like, you got to get through like your basic college math, and then you might have to do like a warm-up class and then do the college math if you forgot it from high school, right? That happens, totally normal. But we have bundled into our AI data analytics program a level 1 statistics class, because statistics are super important for doing artificial intelligence work. I don't want my AI driven robot to go with its gut feeling on whether or not it's going to build that part for me. I want it to have it built upon data that it predicts. Like, it knows it has enough resources, it knows it has enough time, it knows it can build it correctly with certainty. It's predicting it can, so it does. You see the difference, right? So that information piece really becomes very, very important. Um, so statistics, which is once again a thing that you will study, and when you guys go on to like a 4-year degree or beyond, right? Most 4-year degrees usually, especially if you're in any technical fields, you'll have like 2 levels of statistics. Go on to a master's degree, you'll add a couple more layers to it, right? But okay, once again, collecting, analyzing, interpreting, and presenting empirical data. What does the word empirical mean? Somebody Google it and type it and drop it in the chat. What's empirical data? I know it's stuff that I made up out of my own head. Let's see if anybody drops it in the chat there. All right. So statistics are applied every day, it says, in research, um, by industry and government to take, it should say, to make decisions based on scientific evidence. And yeah, so Armando, thank you. Right. So it's information that's based on, concerned with, or verifiable by observation or experience rather than theory or pure logic. So in other words, I'm not imagining this data. I counted how many times I went up to bat and struck out, right? I didn't guess at the batting average. That's my batting average, because that's how many pitches I got, and that's how many times I hit the ball. See the difference? So it's empirical data, means it's real data, right? That we gathered. And here's the weird part of data. A big movement with AI is, and we talked about this briefly already, and we'll talk about it more going into the future, is a lot of AI is used to create synthetic data. Weird, right? So it's not real data, but yet we're building AI with it. All right. All right. So the science of collecting, exploring, presenting large amounts of data to discover underlying patterns and trends, right? That's kind of the goal here. Just a little video here. I'm not going to play this, but they do talk about weather predictions, right? So like, this is and I find this really astounding, that even with all the tech that we have, they get pretty good with the forecasts, like what temperature it's going to be, when it's going to snow, what time it's going to snow, how much it's going to snow. And of course, we're talking about snow because it's winter, but it could be some other time of year, and we're talking about rain and tornadoes and hurricanes and all that kind of stuff. But how do they predict the weather? They look at what the weather did before. Like, when these conditions happened, this happened. The temperature went up and it started raining. The temperature went down and it started snowing. They're based on predictions, and it is really, really important. That it's actually
weather was founded 50
a pretty good video, but I'm skipping it. Sorry, in the interest of efficient time usage. All right. So it's important because it predicts the future. Like what is going to happen often is very easily predictable upon what's already happened, right? Um, People that build and make things, manufacturers, use stats to make things, So, for example, it says manufacturers use stats to weave quality into beautiful fabrics to bring lift to the airline industry and help guitarists make beautiful music. I think that's kind of interesting because I do play guitar. Researchers use it to keep children healthy. For example, um, we're doing a statistical analysis and we're watching the COVID pandemic statistics. And man, when that stuff was happening, this is pretty interesting. When we were first teaching data analytics here at Gateway, we were just brand new. The program was pretty brand new, and we'd start looking at COVID data, and we're like, oh my God, 3 times as many people died today as yesterday. I hope that trend doesn't continue, right? And man, you would look at some of those projections back then. Oh my God, like you would freak out, and you didn't want to leave the house, and who would blame you, right? Um, it's also important because people use it to communicate information, right? And this is a really big thing, right? So people take numbers, they create charts and graphs, and they tell you what they mean, but it can also be wrong. And I want you guys to be mindful of that. They're trying to communicate the information that say, hey, look, you know, um, you know, Seattle scored how many field goals in the first half, right? And then of course I was watching the game with somebody who bet on how many goals would happen in the game, and he was so happy because 4 was the number he guessed, and it got to be at least that many, so he won his bet. you know but I think that's kind of an interesting thing. Communication stats are used to communicate concepts, right? And our governments and the people who run our governments look at statistics to make determinations about things and how they operate, right? So all of those are reasons it's important. All right, rock paper scissors, fascinating game. And by the way, this is one I often give to programming classes, right? To write a computer program that simulates rock paper scissors, right? And what I always say about this game, right? Get like 2 5-year-olds in a room together. They can explain how to play rock paper scissors in like 5 minutes to each other. But then when you start to look at the statistical analysis of how rock paper scissors works and what the actual algorithms are that you have to write to make it work as a game in a computer program, it's a little bit more complicated than you might think, but kind of interesting. All right, I'm going to visit this link, and if I remember right, this is kind of a goofy little thing here. I'm trying to figure out which browser it's going to, which browser window. Not that one. Let's try that link one more time. Maybe behind the scenes here. How about, let me see if it went to one of my other browser windows here. Nope. Okay, it just doesn't want to open it directly. So maybe I'm going to copy it from the notes of the slide and then open it in the browser tab, and let's see if it opens. It did last time I ran it. All right. All right. So this is a goofy little thing that somebody put together. All right. All right, so I'm gonna do this goofy little thing here. This is gonna ask to access my camera. So if you guys want to try this on your own, feel free. Um, so I'm gonna let it do a video capture of my camera. I don't know if it'll let me do it while it'll bump me off of Zoom. All right, it says camera in use. All right, I agree. Let's go. Make a paper. right? And normally, like if you do this, all right, so let me see if I turn off my Zoom camera. Let's refresh this. So now you guys are hearing my voice, but not seeing my face. All right. Let me see if it picks up my hand now. All right. So you guys can see my real background now. So here's my, it's supposed to load. And here's what you guys can do. If you guys want to try this, this is a computer vision exercise, really. Um, yeah, you can see mine is not going to load because I think Zoom is just conflicting with it. But here's what happens, right? It'll recognize your hand, or maybe it's doing it now. Okay, make a rock. There we go. Make a scissors. Okay, I'm not sure what it's looking for there. It's pretty goofy, and I'm recording this. All right, all right. So here we go. Um, okay, of course the computer's going to set it up so it wins. All right, we'll do paper. All right, pretty goofy, but I just want to show you like this is an example of a computer vision thing that you can do. Um, so what's the point? Okay, we're talking about statistics. What about what? Why does this relate to rock paper scissors? All right, here's the question: how many times, on average, should you win? How many times, on average, should you lose? Better yet, how many times on average do you tie and go again? Because all those are possibilities, right? Yeah. So it's really a statistic. Um, yeah. And so, like here, it's like, don't you think the computer was able to predict your move? Yeah, especially when it made me go first. Right. That's not really random, right? That's ideally you both do it at the same time. If you're playing rock, paper, scissors, you don't really want to have the other person uh, seeing what you're gonna guess first, because then they can beat you every time. So you don't really know. And well, how was it able to predict my move? Because it saw what I did and then told me to wait for a second. That's how it did it. Right. But there are patterns, right? And this is kind of what the point is. Like a lot of times when people play rock, paper, scissors, they just kind of have the tendency, like I always like to do rock because rock smashes things, right? Or I always like to do scissors, you know. So who knows? Is it really truly random? Is kind of the question. But in principle, both players would be random, and both players have three choices. And out of those three choices, what are the possibilities again? And I want you to think about this. If I do rock, there's two other choices the other player can make. One beats me and one loses, right? So for everything I do, for every possibility I have, there's at least two possibility and tie, right, Kira? Correct. And tie. So win, lose, or tie. There's three possible outcomes. How likely are those to happen? They're equally likely to happen. 33% of the time you'll tie, 33% of the time you'll win, 33% of the time you'll lose. Well, 33.33 repeating, right? And that's just straight up statistics. So if you completely randomly do that and you do it enough times, that's what the results will be, right? So analytics, and this is an area that we're all studying here, kind of went through eras of development, right? Um, so we're now fully in the what we call the analytics 4.0 era, and this really kind of ties in with industry 4.0. Analytics are embedded, they're automated. We have cognitive technologies, AI basically. We have robots. We have augmentation as opposed to automation, right? So we have systems that are automated. For example, like a thermostat, you set to a temperature, and when the temperature drops below a certain temperature, it automatically or autonomously turns on the heat. And thank goodness, right? Right. What would you do if you had a wood burning stove? Let's cold in here, throw another log on the fire, right? Yeah, that's kind of the difference. But notice that like we kind of move through these eras, and we move through these really quickly. So that this might be like the 70s and 80s, um, 90s into the 2000s, the teens, and now we're in this era, and we're moving quickly, folks. Right. All right. Stats is a big part of AI systems, big time. Um, you know, so they have a bunch of different examples here, and once again, I'm going to kind of rifle through most of these pretty quickly. So we'll look at like use cases in manufacturing. Um, Stats is used in quality control systems, right? So, for example, if I look, say they give this example of like with Audi vehicles, like if I look at a vehicle coming off the line and 1 out of every 20 vehicles has a bad weld, and that's a pretty consistent statistic, they could probably predict pretty accurately that they're going to have a certain number of problems with their cars. Um, they also have predictive analytics that Intel uses in manufacturing. This happens in healthcare, right? So this company called AbbVie from our area, by the way, uh, has over 30 million patients in 175 countries, employs 47,000 people. So if they optimize operations for all those peoples, I always wonder what optimize means, honestly. They use it to find novel patient treatments, medications, and manufacturing. All right. They talk about what toolkits they're using. You notice how they're TensorFlow, uh, OpenVINO, all these things. Those are Intel technologies, by the way. They use AI, and I think I mentioned this that I had a heart scan like a year ago or something like that, and the software they used in the heart thing recommended to the physician to look at certain things that I might have certain problems in the future, and that was an AI algorithm, by the way. I thought it was pretty interesting, and they use basically statistics, to reduce training times often, right? Which I think is pretty interesting. In telecommunications, there's a bunch of companies that are using these statistics to try to figure out, like, for example, like when does everybody make a phone call? Really, actually, how many people are really even doing phone calls anymore, and they're just texting all the time? Or maybe that phone is really more of an entertainment and gaming device, than it is anything else, right? Yeah, and you guys can judge that for yourself. Um, but the thing that they're focusing on here is how they used statistics to figure out network analytics to make faster corrections to the networks when the networks are having problems. All right, another little activity here, and I'm going to go to this website, by the way. Um, I'm not going to really do a demo on it, but I do want you guys to try to explore it. If you're curious about it, there's this website called RAWGraphs.io, and they have both a learning page, and I do have these over here, so I'm going to pull them over one at a time. So this is the learning page. So they tell you how to use it, how to load up your data, right? And then after you load up your data, they actually have the actual usage of it where you can go in here. So for example, data analytics students, which is almost all of you here, if you have a data set, you can come in here, you can paste it in, or you can upload it. And then they can create like graphs and charts and all this like goofy stuff kind of automatically right on this website without loading any really fancy software. Now, what I would challenge you guys to do is, I really don't want to spend a lot of time on this here in the interest of time usage, but this is something that you guys can explore on your own. When we get deeper into the program, by the way, you will learn other tools, like even the some of the pivot tools in Excel perform some of these functions automatically, but later on we'll learn how to use Power BI and Tableau to do a lot of the actions that this website does. But what I think is fascinating, though, if you do have a data set that you can drop it in here and get it visualized, pretty darn quickly, right? Without even having a lot of knowledge, and it's free, you know, pretty slick, right? I'm sure they have paid versions. You know, everybody wants to make money off their stuff, but you'd be amazed how much stuff is actually out there for free that you can use, and it's on the web, and you don't have to install anything, and it's pretty powerful. And this is one of those tools. So feel free to explore that, folks. All right. They asked this question, and I think this is a pretty pertinent question, right? Um, so you're doing like data analysis. Are there ethical concerns involved with looking at data? Hmm, something to consider, right? What we mentioned this before, right? So if you look at statistics for certain things, sometimes statistics tell you the story, and sometimes statistics only give you part of the story, right? Um, and so there are ethical concerns with that because if you're making decisions based on the data and the data is not completely correct, are you making the wrong decision? Okay, so that's how we'll answer that one. All right. All right. So here's the key takeaways from that section of the presentation, right? Uh, Data sets are important for AI. Statistics help us make predictions, help us make decisions, and it's really, it is really truly important for the development of AI. All right, all right. A couple of reflection questions here. Um, so the statistical data enable the computer system to predict and make decisions. Do you think we can give computers the ability to see? Well, guess what? They already have that totally. And how will that impact industries that are going to employ it? Like if I right now have a person who works on a manufacturing line that makes sure that a product is built okay, and how are they doing that? They're looking at it or touching it or testing it somehow. Will that be reflected in the actual manufacturing process? Like, can we get a computer to do the same job? And then what happens to that person's job? I would say you should go study AI and computer vision and learn how to program that machine, is what I would tell them. Right? That's a smart play. That's why all of you guys are smart for being in this program. Because if AI comes and takes your job, what's the job? Programming the AI, right? Making it behave. Totally. Right. So computer vision, which is another primary domain of AI, folks, right, allows computers to see, observe, and understand in principle, right? So you can see something, and this is a great test, right? Like you have two people watch a car accident happen, right? And you talk to those two people, they can give you completely different stories, right? Well, if it's two cars, the two different drivers will give you different stories. That guy was an idiot and cut me off. Well, that person was speeding and wasn't paying attention, whatever, right? Um, but can you get a computer to understand by what they see, what images they're capturing? And I think that's kind of interesting because I was doing the rock, paper, scissors, and I'd have to like first, right, look at my hand and go, oh, that's his hand, that's his paper, right? This is his fist, and this is his scissors, and they're kind of different shapes. But what if I was, missing a couple of fingers and my fist is all like weird? You know what I mean? It's still a rock in my mind. Does a computer get that? I don't know. All right, computer vision is a pretty astounding area of AI. Probably one of the more impressive areas of AI. Um, so we're going to look at all these different questions here and topics related to it. And all right, so what is it by definition? So the point of it is it enables the computers, it says here, to derive meaningful information from images, videos, and other inputs. And importantly, those are all digital inputs, right? So if I have like a old-fashioned photograph, Well, you're going to have to scan that or take a picture of it or something and get it into the computer for it to work. And then when it derives that meaningful information, be able to also take action or make recommendations based on that information, right? Like if you had your computer vision looking at the road and going, it's icy, you shouldn't drive on that surface, you know, that's a recommendation, right? Or an action. It really is truly computer vision is a subset of AI, right? And you will have a whole course on this topic. There is one being taught right now. Um, and unfortunately, I couldn't teach that one because it conflicted, I think, with this class. I think it runs at the same time as this one. So I think Christian's teaching that one. But here's another really cool little activity, and I am gonna like go through this one a little bit more than the others. But there is this AI vision thing that Google has available for free out there, and so let's follow these steps. So first, let's go to this URL, and once again, it's not loading. So let me see if I can extract. Okay, I'm going to go back a slide, folks. Cloud.google.com/vision. So let me bring up my browser tab here. Let's so cloud. There we go. All right. And I want you to notice what it does, right? So it says it extracts insights from images, documents, and videos. And you can try it for free without paying anything. But if you want to use it professionally to do some work, which people do, right? Uh, you're going to contact their sales team and play with it, right? It does want you to choose an account. I'm going to choose my school account here. Oh, okay. So it tells me my school account doesn't have access. So let's go back and see if it asks me again. And then I guess I'm going to use my personal account. And I have to agree to their terms. So I'm going to agree and continue. All right. And then what's our next step here? Scroll down to the try API section. So let's see if we can find that. Try this API. So it's on a button now, right? All right. And then we're going to scroll down here somewhere. Or did it bop me away right away? Let's see if we can find the right thing. And if you guys find it before me, that's totally okay. We're looking for the demo, basically. Um, and for as goofy as this demo is, let me just see if I can. All right, so that's a JSON file, by the way. Is anybody finding it? I thought I just had it earlier in overview. It's going to take me right back to the same spot here. And I think what it's going to do is it's going to, okay, yeah, it wants me to pay, and I'm just not going to do that. Okay, so they've changed it here. They want you to get into like through a paywall, but in essence, what this tool does, right? And I'm just going to go back to the slideshow here. So if you want to, one of you wants to give the free trial a shot, I just don't want to get trapped into paying. Basically, what it does is you can put in an image, and what the image does basically, or what it does with the image is it looks at it and then it starts to label it as what it thinks it is. Right. And this is pretty fascinating. And I think last time I think I had like a picture of one of my pets or something like that. And then I threw it in there and it identified that it was a dog and it was out in the snow and it was running or whatever the thing is. But the fact that you can just take an image and drop it in and it can really categorize it and label it, never having seen that image before. And then the question becomes, how the heck does it do that? How does it know that it's okay, a toy, a machine, fictional character, yada 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 yada. How does it know that it's those things? And basically, it's done through training, right? All right, it says AI can improve manufacturing and defect detection rates by up to 90%, right? So, like, you can use a vision system in place of a human being in that manufacturing line to spot things that a human could never spot. It might just have a really good camera, or maybe it has the ability to see things that we don't because of different levels of light or frequencies of light that we can't see, right? Um, yeah, and I think it's kind of interesting is a 200,000 players analyzed for finding the next football star with AI, and they can look at film of players and look how they play and then have AI determine whether or not that person's talented or not. I'm not sure I like that a lot, right? But do teams do it? Well, when you're watching the game, they brag about how AI is figuring out this or figuring out that. Um, yeah, and another interesting usage uh, to find counterfeit currency, right? Kind of weird usages. Um, all right. How about if you are looking at shopping at a store and you're sitting there waiting in line? What if there was an AI that was going, "Hey, I got 5 people in this line, 10 people in that line. Let's open up another register," and just calls the clerk up to the register. That kind of an interesting thing. They are using computer vision now in a lot of medical diagnostics, right? So sometimes, um, computer vision can spot problems with people like, oh, you've got cancer. You know, we can't detect it in the other tests, but the computer vision system sees it or that it's about to happen. Um, yeah, so I think it's really kind of an interesting technology because it is visual. And you think about like really kind of goofy things like this. Like when you were a kid, how did you figure out what was a dog and what was a cat? Did you see it in a book? Did you happen to have one of each of those in your house? So you can go, kitty is small, the dog is big, unless you have a chihuahua and then the cat's bigger than the chihuahua, right? Especially if it's a well-fed cat. Um, but yeah, so here they're saying by 2022, already past that, the computer vision market was reaching 48.6 billion in revenue. Um, and what does UX mean? It stands for user interface, is what that means. So like, um, computer vision has truly become a user interface technology. I'll just give you an example. Um, you unlock your phone with your face. How's that done? There you go. Right. Have it right on your device already. All right. So with humans, we can look at things, our eye sees it, our brain processes it, and then we learn to label, well, that's a banana, and that's a lemon, and that's an orange, and that's an apple, and that's a peach, and whatever. And how do I know that? Because that's what I was told. Or I looked it up online and there's a picture of an apple. Yep, that looks like the apple. And it's certainly a lot different than the banana. But sometimes you have apples. Well, some apples are green and some apples are red and some apples are whatever. And they're different shapes, right? I mean, generally. All right. But how do you get a computer vision system to do that? It's going to look at the same image, but it's going to have different types of devices. It might have a regular old camera, but it might have an infrared camera, or it might have LiDAR, or it might have some other kind of sensor. It could be all sorts of like electromagnetic sensors, for example. And then it has obviously some computer algorithm that helps it determine what things are. Computer vision technology is not new. Um, and I think it's fascinating to think about in this capacity, because they started working on this problem back in the 50s, right? So like, how do we, you know, get computers to recognize different shapes is where they started. So they were able to figure out like what's a circle and what's a square using camera technology and real simple digital images. From there, in the 70s, we started to develop what we call OCR technology. And I think that's pretty fascinating too, that it's really that old, that we could take documents, basically a picture of a document, and then have a computer system look at each character and try to figure out what letter it is. And then by determining what letter it is, it can turn it into a digital document that we can edit. And that was developed in the 70s. Like, wow, right? And in the 90s, we started to be able to get more sophisticated things. And then finally now, as we're into the 2000s solidly, not only can it detect like what is a person or whatever in an image, but it can describe objects. So like that robot picture that we had on the slide, that it can realize, oh, well, that's a robot and it's got this feature and that feature, and these are all the things that I can label it as. And so I think that's pretty profound. Images, of course, are captured in a lot of different ways. You know, a digital camera is probably the most common. There's scanners, you know, our phones do it, right? Like we all walk around with little cameras in our pockets now. But that is digitized, and digital images are basically like, if you can zoom in far enough, are just tiny, tiny little pixels, each little squares that we put on the screen, and each square is a different color or brightness or whatever, right? And we put thousands of those together and we have a digital image. And that from those little colored squares, the computer vision system can understand what it is. That's pretty profound when you stop and think about it. And it's kind of interesting technology. I am going to play this video and then we will take our break as soon as it's done. I don't know if I can speed this one up or not. We'll see.
In this video we will learn how computers read and make sense of images using a technique called image processing. While we are able to process images in a single glance, the way computers do it is quite different. For a computer, each image is a grid of small boxes where each box has a number associated with it. These boxes are known as pixels. They are the smallest individual unit of an image. The numbers associated with each pixel depend on whether the image is colored or not. For a black and white image, there's just a single number to signify the extent of black being used. For colored images, each pixel value has 3 numbers associated with it to signify the extent of red, blue and green colors in it. Now that we know how computers read images, let's understand how computers try to make sense of it using a simple example. Have you ever noticed that when a kid tries to solve a jigsaw puzzle, they first start with the corners, followed by the edges, then group together pieces with the same colors. Once the above steps are done, they finally start putting the pieces together. Important information like the shape and colors of individual pieces are known as features. The process of choosing important information about the images is known as feature extraction. The process through which the AI model learns to recognize images is something like this. At first, the AI model takes input of a lot of images. Next, it makes sense of this data by feature extraction and undergoes training. Now, when a new image is input, it is able to identify it by performing feature extraction. And then it compares this information with the data it has from previous examples. thus, finally making a decision on what the image is. To recap, we learnt in this video how computers read and classify images. Thanks for watching. In this video we will learn.
Right. Yeah, I don't know how much of that stuff is like new to you guys, like that conceptual knowledge, and I think a lot of people who do any image manipulation realize a lot of those things already, but I do think like the OCR stuff is pretty fascinating. All right, folks, we're going to take a break. When we come back, we're going to talk about the ecosystem of computer vision. Let's do about a 5-minute break, so we'll come back at about 9:01. So I will see you guys then. All right, folks, we're back from break, and we're going to continue on. We're on slide number 74 here. We got a number of slides to go, but you will see some of them will go very fast. So, all right, so we're going to look at these kind of topics here, basically talking about computer vision and some of the things that go with it. All right, so they do have a couple of little tidbits here, and what you will notice that this first technology that they're talking about here, OpenVINO, which is basically a Python library / API / toolkit, is one that we do use for computer vision systems. And since we are, it's a big one in the marketplace for this, by the way. And since we're steeped in the Intel stuff, when you get to the computer vision class, that is one that you will play with. Also, aside from the Python libraries and stuff, we have a bunch of other software tools that Intel has available. And the concept is basically that we have these systems here that already have certain tools in place that allow us to get to the point where we can do higher level type of activities rather than worrying about the mechanics of programming the computer vision system itself, where it is capable kind of like basically out of the box to do certain types of things. The one example they have in this video, and I'm not going to play it, like, for example, like watching the driver to see if he's falling asleep, or the car senses there's an impediment in the way and the driver's looking at his phone, and how does the computer vision see? Well, it just looks at the guy's eyes. Look, he's sleeping, he's drooling, he's snoring, goofy things like that, right? And how we can utilize those things. They also have a couple of other technological things, like this RealSense SDK, and I'm sure this has been upgraded by the time since they put this thing out. But it does interface with a lot of the other Intel systems, as you can see at the bottom of the slide there. And I think what's kind of interesting is, like the process that a computer vision system goes through to kind of figure out what something is. You know what I mean? Because if you look at like a bunch of pictures and you see there's like a ton of pictures on the screen right now, and some of them are let's say complicated images, right? Because it's not just the subject of the photograph, but it's also the background of the photograph and the color of those things and how they sit relative to each other. Like for example, like here you can tell pretty clearly like this image here is a squirrel because the background happens to be white. But you might look at a different image, let's say like this one, where I can see there's kind of a face of a large cat, I think, in here, but it also looks a little bit stretched, and I'm not really quite sure because it's kind of blurry. You know what I mean? And how does it kind of like work its way down? So like a lot of what a computer vision system does is it works from general to specific. So it can go, okay, well, these are all mammals. These are ones that are born, naturally, like the way humans birth their children. Looks like it eats other animals. Probably fits into the canine category. So you can probably call it a dog and not a wolf or a hyena. And it looks like it fits in the category of working dogs. Oh, it's a husky, that kind of thing. So that's kind of how it works, right? And if you think about it, your brain kind of does the same thing. Although I can see a husky or a Malamute and call it a husky, pretty quickly. But the computer vision system actually has a process it goes through to get to the knowledge. But it really is kind of the same process that we go through visually. And the same thing down here with, finding certain kind of boat, for example. So computer vision systems are image based. They're used to identify things. We can use them to control processes and to detect events. Like here's a really good example. Like you can have a computer vision system that just waits for motion, right? So a really primitive example, and I happen to have one sitting up here on my shelf, is I have a trail cam that we sometimes take up north. Um, we had a compost pile up there, and somebody would always come into the compost pile and eat our compost, you know, and we put up the trail cam to figure out which animal is doing it. Is it a raccoon, or is it a deer, or is it a bear, or what is it? And that's a really primitive system. It's just a motion sensor, and when the sensor is triggered, it takes a picture, right? But a vision system can detect other types of events. And I think last week we talked about like traffic systems that are sensor driven. I think that's pretty weird, right? We also have like drones that fly around, and some of these have computer vision systems uh, built built in. We have navigation systems, right, built into autonomous vehicles or robots. Um, I was at Woodman's the other night, 2, 3 nights ago, and that you remember that robot I showed you that like counts the products on the shelf. I had an encounter with it, but I thought was really funny is they had one of their floor cleaning people there that rides kind of like a floor Zamboni kind of thing. And the guy wanted to clean the aisle and he had to wait for the robot to finish taking stock first before he could do the thing, because otherwise the robot would just stop dead in its track and he couldn't wash the floor. So pretty interesting. They can also be used to organize information. So like if you can have a computer system that looks at a bunch of photographs or videos or whatever, you can categorize them. It saves you the trouble. Right? I think what's kind of interesting, is I like use my Google Drive to store my photographs off my phone, right? So I take a picture and it uploads to the Google Photos thing. And then I can go in there and I can search it and say tree, and it'll find a picture of a tree, or dog, and it finds pictures of my dog. And that's built into Google Photos. And there's an example of it. All right. So types of computer vision: image retrieval, right? So like you show me an image of a dog. Well, here you go, right? To detect what an object is. So like to look at a photograph and then identify all the various objects inside the photograph. I think that's pretty fascinating. To recognize your face. We talked about that. Or just to find the edges of objects, right? Well, that'd be pretty important for self-driving car. There's the edge of another car. Don't hit it. That type of thing. All right. There is this other platform, and once again, this is a tool that you really should try. And this is not one that I'm going to demonstrate again, but the demo links are here. Hugging Face is an image recognition tool here, and actually, I'm pulling over the wrong tab. But there is a login that you have to go through to get to it. But Hugging Face is a really big library for doing a lot of AI work. Most of this stuff is open source, by the way, so there's usually no cost for it, but they do track you, for information. Some of these tools, by the way, and let me see if I can even. I'm not sure why it's blocking my mouse clicks here. It's just blocking them today. But some of these tools are pretty interesting because you can, for example, go to the DALL-E Mini and you can say, show me a picture of a dog running through the snow and having fun with some children, and it'll just generate it for you. And I know many of you have played with those kind of features in AI engines already. But what I really want to point out that's fascinating about this is this technology is now so pervasive that the source code for it is open source. So here's one of the secret sauces of AI is a lot of AI is built with open source AI technology that's out there for the taking, right? that's pretty profound, right? And if you have the skills for it, they do talk about Hugging Face as a platform. Um, you know, it they talk about the fact that it does natural language processing and artificial intelligence. But here's some examples, right? So like if you don't know what kind of image you would like your AI to create, here's some prompts you could throw in there. And of course, the reason they give you pre-configured prompts is somebody else has already done these, so it would generate it really quickly, right? Yeah, and so you can try these, and I've done it before. But I think what's really interesting with many of these AI engines, when you give it a prompt to create like an image, for example, most people give it one prompt and go, I'm not really sure I like that. Not thinking that you can go back to it and say, all right, can you change it a little bit? Can you make that thing blue? And then you make that a little bigger and then make that a little smaller and change the background so it's whatever. You can do all those things with these engines. But once again, this is an open source one that's out there for the taking that you guys can experiment with. Many of our big Gen AI engines like Gemini, Copilot, ChatGPT, Claude, all those do this natively as well. And I think it's really, really fascinating. I've been exploring more of those tools in the Gen AI engines than I have in the past. And I'm not into it so that I can create a really cool social media post. I use it for like functional purposes. Maybe I'm building a website and I need an image of something and I don't want to go shoot the photograph. And I say, show me a picture of a whatever, and it just creates it for me, and I can put it on a website and I own it, and it's not like something that I stole from somebody else. And that's kind of some of the interesting aspects of this. It can get pretty creative, so like be really experimental with your prompts, right? As you kind of go through it, they talk about the different parameters, and I don't know if these are all still true, but you can go in there and you can tweak some of these things. And obviously, the longer you let it work on the issue, the better quality thing it can output. I was talking with, when I was at the Super Bowl gathering yesterday, I was talking with a guy who is a video artist that works on big professional productions, and he's talking about how much more people in his industry now, rather than going out and shooting footage of something like a background, and then they would like green screen somebody over it. They just have the AI generate it now, and it saves them a ton of money and time and effort and plugging gear around and all those kind of things. So it is really kind of making inroads. All right. Time for a quiz that we're just gonna kind of go through really quickly here. Right, you guys can do these on your own, so I don't really need to do them for you. All right. So that was the key takeaways from computer vision systems. And now we're going to move on to the next topic here, which is natural language processing. And arguably, natural language processing in combination with computer vision are kind of like the AI revolution that we think about as being the AI revolution, right? So first of all, we'll talk about what it is, its importance, where it comes from, and kind of things it's used for, just kind of the same way we did with computer vision. So natural language processing is the ability basically for an AI to understand and perceive language either in a written form or in a spoken form and respond in kind, either written or spoken. And I know a lot of us, when we use our AI engines, right, like we do a search or whatever, and then we read the results. We type in the search and we read the results. Have any of you here ever used like ChatGPT or Gemini or Copilot or whatever and just ask it a question and have it respond verbally? Anybody ever do that? See Armando's typing there. Yeah, once before. I have a few people I know that always do it that way. Like they never type into their AI. It's like, hey, ChatGPT, how's it going? Can you please do my homework for me today? That type of thing. And that is a total way you can operate with it. And some people use AIs in place of like human connections, which I think is pretty weird, right? It's something I'm not personally comfortable with, but it is being done. Right? Um, all right, so let's talk about what natural language is. Well, here we are. I'm talking to you. I'm naturally speaking to you in the language of English, the language of designation for our school, our country, and thank God for us for programming, coding, uh, commerce, planet wide, right? So English is kind of the language of learning, commerce, and the internet, really, and let's be thankful that that is the case, right? For those of you that speak other languages, and I know there's probably a number of you here that do, um, do I have anybody here that where English was not your first language? Nobody, right? Nobody. Even the people that with names where I would think that it would be not your first language. Yeah. But and ironically, English was not my first language. How do you like that? My first language is Greek, even though I was born here in the United States. Yeah, my parents thought it was very noble that I don't learn any English until I go to school, and that way I'll know Greek and never forget it. And they were right. I will never forget it. But the utility of it planet wide is that it's great if I travel to Greece or go to a Greek restaurant and want to order some baklava or something and say it correctly. Um, but otherwise, the utility kind of falls short, right? English, on the other hand, is one of those languages. There are many languages that are really useful, like English, French, Spanish, German, Hindi, Arabic, Mandarin, I can go on and on, right? Where there's, millions or billions of people speaking that language. Um, when we first developed NLP, right, they first called it NLU, for whatever reason, natural language understanding, because that was really the first hurdle, right? Is to not only get the words, but to understand what those words are. So if I say apple, it understands what an apple is. And if I say dog, it understands that it's not a cat, those types of things. But it does combine a bunch of different technologies, which is what they're pointing here, right? So computer science and programming, obviously. We have to intermingle it with AI, right, to get like the deeper algorithmic meanings and whatever, but also the study of linguistics, which, okay, here the stat that they're throwing is that there's over 6,000 human languages on this planet. Interesting, since there's only 178 countries, right? But some countries have multiple languages, and let's face it, a lot of people do speak multiple languages, and that's not really abnormal. It's abnormal for Americans to speak multiple languages. It's not abnormal for other people in other countries to speak a lot of languages. Um, when they started developing this tech, right, they had to really start to break down the features of language in order to be able to understand it, both from the standpoint of like if I'm looking at words, the ability to read them, right? Whether it's like, typewritten or handwritten, right? And think of how like messy your handwriting can be, or like if you write cursive, how ugly that can be. Um, and then we're also kind of combining it with other technology. So they started working on this back in the 50s once again, and then they started applying statistical methods in the 80s, and now into the future we have machine learning and deep learning models that have really accelerated the natural language process. But the principles of what they were doing were in place a long time ago. Here's what happened: they didn't have the tech to drive it. They didn't have the hardware or the software capabilities to make it happen. Well, now we have tons of computing power. Heck, we all walk around with supercomputers in our hands in the form of a smartphone. And so the processing power is there, right? So linguistics basically focuses on grammar, sentence structure, stuff like that, and all the stuff we hate to learn in school. If we're looking at handwriting, they have all these like if else statements to try to figure out like like what letter is what. And then we also have uh, already specified rules, and they say ontologies here. In other words, like if you want to learn like how to speak English, you could just get a book that says how to speak English, and it'll break it down for you depending on what language you're coming from, and it'll tell you how sentences are put together and how words, what letters sound like, and what order the words should go in, all that stuff that you learn when you learn how to speak. They tried to do this basically with that type of approach initially, but very complex to maintain. Can't scale. That means they can't make it a bigger, more complex problem, and they can't generalize because heck, I can say the word two, two, and two, and you don't know which one I'm talking about, right? Or I could be boring, or I could be boring, like tunneling, for example, like that type of thing. You just don't know. And the words are sometimes spelled the same way. So context becomes important. In the in Starting in the 80s, they started to use machine learning models to process language. And this is a really fascinating part about machine learning is, and I try to mention this before, like it's great if you have a manual like how to speak English and how to put together the English language. Great, you can just follow the manual, right? Like putting together a Lego set. Just put this piece on that piece, and that's how it works. But what if you've never heard a language before? This is kind of an interesting thought. You go to a different country, you speak a language you've never heard of before. Eventually, you would figure out how to talk it, like if you wanted to communicate with somebody. And how do you learn? Well, somebody would probably grab an object like an apple and say whatever the word for apple is in that language. And now you have an association. Oh, so whatever, in Greek, we say milo is an apple, right? And in English, we say apple. Okay, so now I have that association between those two words. So the fact that machine learning in principle can learn a language without necessarily being taught the language is fascinating. How about that for a weird thing? Just enough exposure to it can teach it the language. So they did use both what we call supervised learning models, where they give it a basis, like this is what this word means, and this is a verb, and that's a noun. But the unsupervised approach is where it learns on its own. And I think that's really kind of bizarre. Because we're using machine learning, the deeper layers of machine learning are called deep learning. And deep learning models are able to do things like categorize things. Like, so for example, I could give like that Google Vision thing that we were sort of trying to use. Like I could give it a picture of something, and it can look at the picture and then verbalize what it is. That's pretty heavy, right? And computationally, how do they go from one to the other? And once again, the deep learning refers to the number of layers in the neural network. And it says traditional neural networks of basic machine learning models have 2 or 3 layers. Deep learning models can have hundreds or thousands of layers in them, right? Kind of like a human brain. All right. So when we start talking about NLP as a technology, we start to talk about some of these words. I'm not really worried about you memorizing these in any way, shape, or form. But we listen to a word, right? And a word has sounds, right? So sometimes words have multiple syllables, right? And each syllable has a sound, and then we put those sounds together and it makes a word. But some words only have one sound, and some words have multiple sounds. And some, you say potato, I say potato, but we're talking the same thing, right? And they sound different, and how do you say potato in a different language? Well, in Greek, we say patata, so it's almost the same word, but it's not really, you guys know what I'm talking about, right? There's also syntax, like how you put the words together. Like in English, we will often go subject, verb, and object, that type of thing. Like John ate food, that type of thing, right? And so there's a correct order. But if I go to a different language, like any of you guys that know how to speak, let's say Spanish or any of the Latin style languages, you understand that sometimes boy, the verb and the noun are wrapped together, or we put them in a different order, or it has a gender preference to it. You know what I mean? Like even verbs, that kind of thing. So every language has got its own order. And then how do we put those together into sentences and then get a whole paragraph and then have a whole meaning from it? And this is the era that we're in now, that we have natural language models that can do those things. And it's very sophisticated that we got to that point. Now we can just use them, right? So different levels of this. So they show you like the basic, like how they broke these problems down. And now we're well past the deep learning point, and the models really do have a pretty darn good understanding. And we see it in action a lot. So here's some situations in which natural language processing is used that you might not think about. You go to your Gmail, right? Or other email service, if you will. But I use Gmail as a really good example because it has a pretty automated filtering system, so that when a message comes in and it knows it's probably bogus, it puts it into the spam folder. Or like in my personal Gmail, it does split things into social, promotion, updates, forums, or whatever categories I want. And it does so automatically, right? The thinking is that the stuff that then ends up in my inbox is actually more important. It isn't, not always the case, but whatever. We also see natural language processing in our search engine results, right? Because think about it, you go to Google and you don't type like, I don't know, like a singular word necessarily and look for its meaning, but you'll ask it a question like how do I fix my washing machine? That like, and you'll have a very specific thing that you ask it, like you would, like you're talking to a human. And now you get AI responses that are like, hey, well, if you want to fix your washing machine, first you need to tell me what model you have, that kind of thing. And whatever. Sentiment analysis, right? All right, and this is kind of a scary one, but the fact that AI analyzes our social media stuff, and they're figuring out, folks, like, you know, if you're getting an ad for something, it's probably because some of the discourse you've had on social media. If you are speaking negatively about Republicans or negatively about Democrats, it's probably going to give you stuff that reinforces your thoughts, because it figures, hey, this person hates frozen pizza, so let's not show them any frozen pizza ads. Let's show them an ad for a great Italian restaurant. They can go get the pizza in person and it's not frozen. It's just like goofy stuff like that. Like, do people like stuff, right? Here's another one. You're typing, word processor, email program. I put somebody's name in the to field of an email, and then I click into the body, and it already says, hey, George. I just press tab and I collect it, and it's like, hey, if you want to get together later, it'll auto complete my sentences for me. And do you fight that, or do you go with it? And do you notice, like, especially in Gmail, if you do that, it learns to, like, what stuff you always type. And then as soon as I start typing it, like, one of my standards is like, if you need some help, send me an email, and it just auto types it for me. Translation, right? So we can go to Google and just type translate German to English or English to German. And it happens, right? And you can type in some words, or you can speak in some words, and it'll do it. I had a funny experience where my wife and I were out socially. We went to a place to see music, and there was dancing and whatever. And there was this guy from a different country there, and he was really getting into it because he doesn't experience anything like this back home. And he didn't know how to speak English, so he was talking to his phone. I think it was like Russian or something like that, pick a country over there. And he was talking to his phone, and then he would like show it to me, and he would point to the translation, and he goes, this is great. Is it always like this here? Can I buy you a drink? Or whatever. And people do that on the fly now, right? We were almost like watching, like being in a Star Trek episode, where it automatically translates something. But it's getting to that point, right? And you know what? Language translation, this is a really weird one. If you are somebody that does not speak English natively and you go to class and you don't understand the person lecturing, Gateway has devices you can sign out, no kidding, that will translate in real time as a person is talking to the language of your choice. How mind-boggling is that? We have them at Gateway. Crazy stuff, I think, right? All right. Voice assistants, right? So Siri, Alexa, Google, whatever. Those are things that we are very accustomed to now, right? Um, so those are very, very popular. We also use natural language processing for targeted advertising. I was talking about that before. All right. So here's kind of a weird little activity. And once again, I'm not going to do this here in class. And this is one of those things where I would task you to do this on your own. Um, and this is really kind of a fun activity, actually. But the point is to go to a Gen AI engine, and here they're using ChatGPT here as an example. And I have one that I think I had loaded up. You know what? I can bring up ChatGPT, but I was working with the Manus AI engine, and this is originally a Chinese company that just recently got bought out by Google, by the way, right? And what's the question they want me to ask? I asked ChatGPT to introduce yourself, and here's the response, right? And of course, this changes over time with every time the model upgrades. Um, Please introduce yourself. So I'm asking Manus to introduce itself, and let's see what it does. I'm really curious. Oh yeah, who owns Manus now? Does anybody know that question? This is owned by Meta, which is the parent company of Facebook, Instagram, etc., WhatsApp, all those. And this was one of my favorite ones because it's really a pretty powerful one and very, very fast. Right. So let's see I'm really curious to see how it introduces itself. And it is using the light version, which is maybe not the model I should be using, but oh yeah, it wants me to pay for the other ones. It says, I'm Manus, an autonomous general AI agent created by the Manus team. I'm designed to help you a wide range of tasks from gathering data analysis, building websites, generating creative content. How can I assist you today? So there you go. Not a very, how about this? Can you tell me what technology allows you to understand my questions? So now it's thinking, right? So it's not just blurting out an answer. And notice what AI and NLP technologies, deep learning, transformers, large language models, which, et cetera, et cetera. And it has, this is a really interesting feature, but it runs a computer screen on the side, and you can actually open the computer and watch the work that it's doing on the side. So it's usually working on a Linux system of some sort. And this is one of the reasons I like this engine, because you can see what it's doing. So it's showing you its thought process as it's building the response that's coming to the screen. This is kind of interesting. So one to explore, and I'm not pushing you guys to use this system, but it's not just ChatGPT out there is kind of the point. All right. So it's a really kind of fun thing. Try it with all the different AI engines, see what they give you. The responses that they show here are somewhat dated. They have a link to Gemini and a link to ChatGPT. And you guys should know how to get to those already. Copilot, of course, is Microsoft's big product, and there are many, many others. And notice what the task is here, kind of what I was doing, which is open these up, and you should do this as an activity for yourself, right? If you've never done it, especially, and communicate with it and ask it, how does it work, right? And notice what the prompt is. ask it to write a paragraph on how it works because it might just give you a sentence otherwise, you know. And if you want it to be verbose, ask it to be verbose. If you want it to give you sources, citations, things like that, ask it for that and it will do that. And you know what? You will discover that none of them are equivalent. They all give you different types of answers, even if they have some of the same core libraries. All right. Um, if you want to experiment a little bit, once again, they have a bunch of different prompts you can try. And I think these are kind of interesting because when you start to experiment with these generative AI engines, and it is something you guys should do, right? And I say it sincerely, not all of them, I think, are equally suited to the same types of tasks. So, like when I'm trying to do certain types of work, I have certain engines I go to because I like the responses they give relative to that type of activity. Um, so for example, if I was having an AI agent create a whole website for me, and I've done that, right, where it just does all the work for me, and then I just go in there and customize it, I might use Manus to do that. If I'm asking an AI agent to develop a lesson plan for me, I'll probably use ChatGPT. If I'm writing code, might be ChatGPT or Copilot or Claude, depending on which language and how complex it is, that type of thing. And you experiment. But here's some prompts you can throw in. And what I think is interesting is take the same prompt and give it to all the different AI engines and see how they respond. It's proof that their models are different, right? They have different training behind them. There's also kind of this little bit of an art, if you haven't figured it out yet, in how you orchestrate your prompt. The more specific and precise your prompt to the engine is, the better your results in output. And if you don't like the results you get when you first ask, refine your ask. It's like, asking your kids where they were late at night. It's like, well, maybe you got to change your question a little bit. Because maybe the question will a more precise question yields a more precise response. And what they like you to do too, and ideally, is you would document all this, so you will if you wanted to do the whole process, you could do that. But there are differences between the engines. I do want to remind you guys that here at Gateway, we have expanded free usage of Gemini. And we have expanded free usage of Copilot because of our agreement with both Microsoft and Google. They are not completely free, though. Right? I just want you guys to be aware of that. ChatGPT does sometimes give out free, like 1 year, like pro level trials. But otherwise, what you will run into is limitations. So if you ask it too many questions in the course of the day, it'll cut you off. Right? Especially if it has to think really hard about the answers. All right. All right, now we're just going to start looking at some specific use cases here. We're going to try to do this as quickly as we can. We are near the end. Looking at big sectors of the economy once again. So we have things like, from the consumer standpoint, facial recognition. All right, as goofy as it is, here's an example. And I forget who did this last week in one of my classes. Oh, I think it was I don't know if it was in this class, but for example, I can go to Zoom and turn on an avatar and it's moving, it's following my head position. Let's see if it doesn't, no, it doesn't do my arms, but nodding my head, smiling, eyes wide open, eyes shut. I don't know if it shut my eyes or not, but whatever. Tries to move the lips along with it. Pretty cheesy effect, but that's built into Zoom, right? So very available type of technology. Augmented reality is something that we can overlay on top of objects. So if you guys have ever been use your phone and do Google Street View, and Google Street View will overlay information about a place you're pointing your camera at. That's pretty cool. And then we have robots. And I told you, like at Gateway, at our engineering campus, We have a robot called Temi that'll walk around and talk to you, and you can use it to do tasks and ask it questions and all sorts of goofy stuff like that. Here's a whole collection of videos. Once again, I'm going to task you to watch these on your own. Where in healthcare, it enhances efficiency, can detect diseases and problems, and also help practitioners give better patient care. And the thing I always mention, just like with like computer people, healthcare changes all the time. There's no way you can keep up with it and retain all the knowledge and keep it in your brain. So I think it's kind of okay that our healthcare people are like, I'm not sure what the answer to that is. Let me ask ChatGPT. I'd rather have them, figure out the right thing, even if it's with AI's help, as opposed to the wrong thing, and they give you like the wrong medicine and it kills you, that type of thing. Why not, right? If it makes things
someday
better.
your doctor might look like.
All right, sorry about that. In finance, it's used to do fraud detection, to figure out if loans should be given out, or to mitigate risks in investments. In industry, and once again, we have a whole series of videos here. We use it to automate factories. Here's a vision system that looks for bad parts and how we can do agriculture a little bit more precisely. Like one of my favorite examples is where you get like a robot that does weeding that can tell the difference between a seedling of what it's trying to grow and a seedling of a weed, growing, and it pulls the weed before it even has a chance to grow. Amazing stuff, right? Sorry if the videos play here. All right. In transportation, we have traffic systems that are intelligent. We have parking systems that are intelligent. Have you ever gone to parking structures? I'm trying to think of if we have any around here. I know like Bayshore Mall up on the north side of Milwaukee has a thing that tells you how many open spots of parking there are. I'm not really sure how they work that. And I don't think it's necessarily looking at the parking spots. I think it's counting the cars going in and out and then tells you how many spots are available. I think that's kind of interesting. Also, the driverless cars. And we don't see them here yet, right? Although there's cars on the road that are capable of doing it, like Tesla's most notably. But there are states, California is a very notable one, that already has autonomous vehicles and robo-taxis and all those things happen. So that is technology that's here and almost here. All right, and then it wraps up with a quiz, right? Like not like these are super important, but here are the answers if you care. Key takeaways from natural language processing. And I think, in many ways, maybe natural language is maybe one of the more impressive areas. You combine that with computer vision together. And that's really kind of what the AI revolution feels like right now. The capabilities that we're not really talking about deeply yet is the ability of AI to generate new content. And that's why we call it generative AI, where you ask it to write a piece of music or create an image or create a story. Excuse me. All right, so these are kind of some of the reflections that we have here, and we are doing a wrap up here, folks. So we are just about done. So I'm just going to rifle through the last couple things. There's a guy that looks pretty happy that we're done. Here's our bibliography, which I'm capturing into the video. So this is where all the source materials come from. And there's a second page of it. And folks, that's a wrap. So this presentation ends here.